Did you know that there is a way to fly to a neighboring star in 1 hour without exceeding the speed of light? The nearest star to us is Alpha Centauri, which means that I am talking about a speed of 4.3 light-years in 1 hour. Put on your foil hat so your brain doesn't explode. Let's go! But first we need to learn what time, distance, and physical symmetry are. What is 1 hour of time anyway? A clock with an arrow immediately comes to mind. And for many of us, that is what time is. But the secret is that there is no such thing as time. Time in nature is the rate at which physical processes occur. Some processes are cyclical. For example, an atomic clock measures the number of vibrations within an atom. But it's not just vibrations, it's an exchange of quanta at the subatomic level, and it happens at the speed of light. Let's imagine 3 segments of equal length. Let's put a light bulb in the center and mirrors on the edges. Also, we need a kind of clock, in which light will fly along the y-axis, creating the very periodicity that we call time. Now, if we blink the light bulb, we will see after 10 periods all 3 reflections come back at the same time. Since the speed of light is equal in all directions, we can assume that all 3 sections are of equal length. This circuit would be a simplified model of the exchange of quanta within atoms, where the center is the intersection of the symmetry lines, both vertically as well as horizontally. By the way, symmetry in physical interactions is the key condition for the existence of matter, and in practice, everything is more or less symmetrical in atoms. The problems in symmetry begin if we consider the scheme in motion. Let's say it is a third of the speed of light. The speed of light does not add up to the speed of the source, so when the light bulb blinks, the light will fly around in a circle, and we will be moving inside this circle. As we can see, the reflected light along the axis of motion will come late, and this is a clear violation of symmetry. And as a consequence, we should observe differences in physical behavior of atoms and matter in general. But we all know that physical laws do not change according to the speed of motion. Scientists have conducted hundreds of experiments to test for symmetry breaking, and they all show that waves will always come at the same time, whether we're moving or not. Even if you change the direction, it will still not break the symmetry. If anyone is interested, I will attach a link to the Wiki-Michelson interferometer. It's the same with matter. Whether we move or not, it does not change its structure. There is an incredible hypothesis that offers a solution, namely that matter shrinks as it moves, thereby restoring symmetry. And the faster the motion, the greater the compression. So the atoms have to contract in order to maintain symmetry. Let's compress our scheme and check it out. Now we observe that the waves are just as divergent in a circle as before, but because the mirrors became literally closer, the light in the center returned simultaneously from all directions. So, symmetry is restored. This is called Lorentz length contraction. All the links are below. But here's what's interesting. The clock, all this time, has been moving with us. And as I said before, the processes inside go through space, and so the clocks are also shifting relative to the circular waves. As a result, the frequency of the 10 periods in the moving clock will be different from the original frequency. In simple terms, the time in motion will slow down. And matter is contracted in the direction of motion. Let's take another close look at our diagram. In reality, we only have a light bulb, the same distance to the mirrors, and a clock. And we can't actually see where or how the light goes. We can only measure in how many periods the light will come back. There's no way of knowing in what order the reflections occurred, as well as how much time light spent traveling before and after the reflections. To the observer in the center, all distances will seem equal because the light came back at the same time. And the most striking thing is, they will not notice any contraction or change in time. And the most important speed of light for them will be the same. After all, light traveled the distance in the same amount of time as it did before it started traveling. This is why the speed of light is said to be constant for any observer. Now let's compare the two schemes. From the point of view of each system, the speed of light, distance, and time will look normal. Everything is as usual. But it is worthwhile to look from one system to another. We immediately notice that time and distances will be different. To move from one system to another, physicists use Lorentz transformation, essentially contraction or stretching the system with correction for time dilation. This is called physical symmetry or invariant. In each system individually, the perceived physical laws, time and distances, will be the same, but if you compare the systems, they will not be equal. The difficulty is that it is impossible to determine true velocity. The locality of time and contraction make these attempts pointless. If one considers only equations, then the question arises, who then moves relative to whom? Either you are flying past the Earth or the Earth is flying past you. Hence, so many paradoxes. We need some kind of reference point to determine our true velocity. For example, there was an attempt to determine motion relative to the ether. Unsuccessful, I will explain why later. But there is such a reference point in the universe which can be seen from everywhere. This is the cosmic microwave background, which is kind of left over from the Big Bang. Its frequency is more or less the same on all sides of the universe. As we move forward, we will run into the wave, thereby increasing the frequency of light into the blue spectrum from the front, and from behind the frequency will shift to the red spectrum. So there is a simple way to determine the speed. Consequently, we can always know who is moving relative to whom. Speaking of the theory of relativity, it's impossible to ignore the elephant in the room, namely the ether. In the 19th century, almost all scientists were convinced that there was a space-filling substance or field as a transmission medium in which light travels. Many properties of light are difficult to explain in any other way. The most obvious is that the speed of the photon does not add up to the speed of the source, from which the slowing down of time follows. Not the most obvious. It is the contraction and stretching of the light wave as gravitational waves pass through. See my video on this? Many experiments have been done to detect motion through the ether. They were based on the Michelson interferometer, the same principle I used in my circuit. The experiment did not detect any ether, and not surprisingly so. As I showed above, the locality of time and physical symmetry makes it impossible to detect ether. As a result, the system always maintains its symmetry. And so, Michelson's experience cannot be applied to the search for ether. Nevertheless, no one cancels the theory of relativity. It just does not need absolute space. It is only capable of predicting the difference in time and length contraction. But that's like determining a 2 hours difference on a clock with an indeterminate number of hours in a day. If we use cosmic microwave background as a coordinate system, it limits the applicability theory of relativity, and it removes a lot of paradoxes. But back to our hour-long flight to Alpha Centauri. So, if the velocity of the ship is that fast, yep, the ship will fly the distance to the star at almost the same speed as light. That is 4.3 years by the clock on Earth. But during the flight time, only 60 minutes will have passed on the passenger clock. As a result, we exceeded the speed of light on our journey 35,000 times without violating any law. To some extent, the limitation of the speed of light is local. If we measure the distance traveled in absolute space by the clock of the rocket, then it turns out we have no speed limit at all. We can cover any distance in minutes. To summarize, our entire world is a complex relationship of energies at the speed of light. And this imposes fundamental limitations on the study of nature. We are trying to measure the world with a rubber tape measure on the run. Our observations are just fanciful plays of light. And all indications are that there is space-filling substance or field as a transmission medium in which light propagates. Gravitational waves that compress and stretch space-time. Stars and black holes that distort space-time. The physical vacuum that is bubbling with born particles out of nowhere. All indications are that space is not empty. My goal is to understand nature, and to bring knowledge back to an intuitive level, preserving the accumulated scientific experience and logic. I plan to release new videos in the near future, according to Earth time, of course, so don't forget to like, share, and subscribe. Everyone, You can take off your tinfoil hats, and I hope your brain is still intact. Have a good space time.